guys are ready. I just forgot, thanks. So we're going to just keep prompting the user over and over for a score. Now we're going to save those scores in an array and then use a loop to go through the array to add up the scores. We're going to eliminate the highest and lowest scores and print out the average, the highest and the lowest. So the example that we're going to work towards today is going to get you close to that, so you'll have a good example to be working with. Let's start out with some real basic things. I'm going to create my new project. I know you guys created a solution last time. I'm going to go ahead and create a new one because I didn't create one with you. I'm going to call this Chapter 4A. You know, it's having a hard time figuring out what to call it because in our textbook it goes backwards to Chapter 4 for arrays. So I'm going to say 4A for arrays. And I'm just going to call this projects. It's going to be all of our example projects. This first project name, instead of Console App 2, I'm going to name it Basic String. I'm going to go ahead and rename my program.cs to be basic string also. And in our main then, I'd like to create an array of strings. So how would I do that? String. String. And then what kind of brackets do I use to indicate that I'm going to have an array?
The flat squarey ones.
The square brackets, that's right.
What are those called?
Square brackets. Oh. Is there other names for them?
I think so.
You guys let me know.
I used to call them the flat ones.
The flat ones? There may be some sort of super scientific name. So then we want to name our array. We'll just call this names. And in this array, I would like to go ahead and set up some initial values. So let's just put a few names in our array. Joe, Sam, Bill. We'll create the most basic names in the world. Yeah, in the United States. The most basic names in the United States. I'm not having a worldwide view. Is it working for you? You're okay? If it was fighting you back. So then I would like to print those out. What kind of loop should I use to do that?
You can use a for loop.
I could use a for loop
Or a for each loop.
or a for each loop. Which one would be more beneficial?
For each.
Let's try our for each. I'm going to put in my using static system.console. And then in my for each loop, I know that I start with that keyword for each, and then within parentheses, I'm going to have my for each criteria. So I know that I have to say what collection to use. I'm going to be looking in names. I'm doing it backwards here. And what are the things that are in my names array? Well, each of those are a string. And I would like to call each of those strings item. And then I can just write out that item.
I'd like to pause this display when it's done. Should I put the read statement right after this right line?
No, after the curly bracket that closes the curly.
Okay, so my end of my for each and then my read. Is it true that hypergrade doesn't get upset about read, but gets upset about read line?
I get upset pretty much every time.
Either one?
Yeah.
Read key?
Yeah, it doesn't like read key.
Oh, it's read key that gets so upset about.
He gets it fussy.
Just such a jerk. Does it work? Did you get it to work right? Great. So now let's change this. What's the matter? Didn't work?
Yeah, it doesn't work. On item, it says, cannot resolve symbol item.
Get rid of that semicolon in your for each. Can I show, I'm going to show everybody that.
Because that's a really common error. So if we were to, if we were to close our for each statement with a semicolon, then we wouldn't be able to access our item variable within the for each body because we've already closed the for each body. So there is no item variable. So our item variable scope is limited to our for each statement. So that shows us that really well. Okay, so that's great. We've got our names array here. Now let's create a loop to prompt for some different names. We'll write out some sort of nice message like, please enter a name. And I'll create a string, one name, and read in. And I'm just going to replace Joe's name with whatever name I just read in. So how should I create that line of code that's going to replace Joe's name?
I know you have to use the, because Joe is the first one, you have to use 0.
Uh-huh.
I'm not sure how to write it.
Would it be, I think it would be names, bracket,
Names.
0, plus equal 1.
That sounds good. Perfect, you guys were right on it. So we want to know that index value, and we've got to tell it the name of the array, that collection that we're working with. Now let's duplicate our for each statement and make sure that we've got that updated name. So we could write out a nice message, right line, updated. And let's see if we can get that information out. So now we've got our revised list there instead of that original list. So could I just create a method maybe to do this for each loop so that I wouldn't have to keep duplicating that code? Let's do that. I'm going to come to this curly brace that's the end of my main, and I'll go ahead and label it. And I want to create a method to output our array. So our method is going to need to have access to the array. So it's going to expect the array as an input parameter. So for our method, we are not going to return anything from this method. So it will be void, and we'll call it print array, and we'll say that it expects an array of strings. And we'll just call that INP as input. Now our for each loop then can say that each item is still called item, but instead of saying in the list or collection of names, we want to use our new collection, INP. And then we'll right line each of those items. So whenever we're using an array as a parameter, we just specify our data type using those square brackets so that the system knows that that data type is a collection of those items. Now to call our print array, first I'm going to go up here to line 21 where we called it the second time, and I'm going to select all of those lines of code and change them to use our print array method, passing in our names array. Now it's complaining at me. It's saying that I can't access this non-static method print array. Why was that? We were talking a long time ago about how our main was a static method, meaning there's only one of them existing in memory for our app. And anytime we call any other method from our main, it has to be static also. So I've got to make this print array into a static method. If we were using a separate class, we wouldn't have to do that, right? Because we would be calling our method from a method that was not the main, not static. So we would have the option of doing it if we wanted to. Without the static? He's just magic. We'll show everybody just a sec. Let's fix it. Okay, I want to go ahead and call it in both places, and then we'll look at his magic code. So under our first for each loop, I'm going to update it also to call our print array method, passing in our names. Now we should be able to run and see the exact same output. We shouldn't see anything different. But we created a nice method to take care of that printing so that we wouldn't have to worry. Do you want to show everybody yours?
Sure.
Is it working without being static? Let's see if we can tell why. Okay, I stopped sharing. See if you can share yours.
This plays all class. I had issues trying to actually put a for each inside a while.
Oh, we replaced it with that print array call also.
Oh, okay, so.
Yeah, I know. But I try to put it in a while because I get counted there. But they'll figure it out later.
Thank you.
So if you notice with this, take a look at it, everybody. This is like an inner method. So this method print array is actually within your main method, right? It's within the curly braces. So we need to move it outside of the main method, and then it should gripe at you about needing to be static.
But we can do an inner method like that if we want to be super secure and not have that method available to any other code. So it is something that we can do. So it's a good one. Great. So I think that this one looks really good. I don't really want to do anything else to it. Let's do one more thing. Change my mind. After this last print array here, let's update. Let's set our second entry equal to the third entry. So I just want to say names, whoops, sub 1 would be my second entry, right? I want to set it equal to names sub 2. And then call my print array again. So now, in our little example here, we should be able to have code that shows us how to create array, how to update values within the array, and how to swap things. Let's run it and see if everything's working. I'll make it Jill this time. Jill, Sam, Bill, Jill, Bill, Bill. That worked. Bless you. So everything looks good in our sample. It's a quick example for us to have some code. If everybody's okay with that, let's create a new project in our solution. This is going to be a console app. And we're going to name this Windows message box. Because we want to get this set before we do anything else. Now I'm going to rename my program.cs to be Windows message box. And we've been working with all of these console applications, which is great. But whenever we are out programming in the real world, most of the time, you guys know, we're working with some sort of graphical user interface, like a website or Windows Forms or something like that. So a lot of our console-based practice is just that, is practice in logic and figuring out how things work, because we won't do a lot of console interaction normally in the real world. So yeah, let's figure out how to make a Windows message box pop up in our application. And I want to do this as kind of a test because I don't have it down perfectly well. And so it could be messing it up. So the first thing that we want to do is in our using clauses, we want to add system.windows.forms. I might not.
Using directive is unnecessary.
It's unhappy. So it doesn't like my form. It is forms. Okay.
But it's mad at that too.
Now let's see if I can get it to work. To use the message box class, you need to add a reference to the system.windows.forms class using Solution Explorer. So in Solution Explorer, yeah, let's add a reference. So find your references under our Windows message box project and right click and choose Add Reference. Now, what we want to find here in this reference manager, we have this middle section is all sorts of different options or different things that we can add. We want to find system.windows.form. And when you mouse over that item, the checkbox will open up so that you can check it. And then you can click OK.
There we go. Trying to find a reference. It's in alphabetical order. No, I'm trying to get to the screen that she had. Oh,
Oh, just right click here on references and choose add reference.
yeah, actually, I'm not seeing that thing.
Under your project, are you seeing your Solution Explorer?
Right, yeah. Whatever you named your project. It's under add. It'll have reference there too.
Finding it? Do you want to share your screen? So,
I am currently not on Zoom, so give me a minute.
that's okay.
All right, hang on, folks. I'll be there in a minute.
You're fine. It's probably something that will help everybody else to know. Okay.
Launching right now. All right.
Well, he's getting there. Setting this up to use the message box is just so you can do some of the examples in the chapter of that PDF document that I gave you. So you do not need to do this for your hypergrade assignment. As a matter of fact, hypergrade would get very mad at you if you did.
Oh.
So this is just so that you can do those examples.
Right.
All right, so what's it doing to you?
So where do I need to go to? Right click in class arrays too. Right here.
Mm-hmm.
Yeah. Go to new. Add. Looking for it.
Do
Above.
add.
It's right under edit in arrays class 2.
Oh, right here? No.
Right underneath.
Oh, here. Yeah, there. Thanks. And you click on reference. Reference. Got it. Okay. Weird. Now what? Click on browse. Huh, there are all your references.
It's got nothing. If you click browse down there, do you have anything? Can you see those system? No.
No.
So it's not the right reference manager. Let's cancel out. Cancel there again, and let's try your project properties. This is something that we all need to do anyways. Right click on your project
Right.
where you are in class arrays 2
Okay, right click on that
and go to properties.
properties. Got it.
Now, in your project properties, we want to set our output type here.
Oh wait, I might have just found the problem.
Did you?
Yeah, his target framework is .NET Core instead of .NET Framework.
Oh, good job. Will it let you change that?
I can start a new one with a framework.
Yeah, let's start a new one. For everybody else, we want to change our output type from console application. What are your options there?
My options are
Yeah.
Windows application.
Windows to
class.
Windows application.
So we go ahead and create a new one.
I'm gonna stop sharing my screen.
Alrighty, thank you.
Thank you.
Good job.
Guys.
So we change it to Windows application.
So we want this Windows message box project to output to a Windows And notice with your project properties here, there is no OK button or anything. It's dynamic. As you make changes, they're changed. When you look at your project properties, there's some other things going on this page that you might be interested in that we hadn't really looked at before. Here, we're just looking at some of our general application properties. We could change the icon if we wanted, if you wanted it to have a different icon up in the corner. So that's a place where you could do that. Now, to close the properties, we just close that tab.
Should you save it?
There is no way. It's automatically saved.
We can control save. It works, 'cause there's a
Control
little
save.
asterisk in the upper
Is there a
right.
little asterisk, or do you save all?
I just take control save
Control save.
and the asterisk over it. So that we save.
So it had a project outstanding
That way it
update.
doesn't do anything.
And we want it to be going, we're outputting to a Windows application.
Yes, Windows application. Mhm. Now, I want to make my Windows message box my default startup project too, so that when I run it, it runs that one. And then I'm going to put some code in this application. And I want to create an array of strings again. We'll call it names, and we'll put in some nice short names. Really boring. Great names. Okay. Now, I want to build an output message. So I'm going to create another string variable to hold my message. And since I want to add to it in my for each loop, I'm going to go ahead and give it an initial value of a null value. So it's got nothing in it, but it doesn't have any leftover garbage, because we're seeing what that leftover garbage does when you're using REPL, huh? That's what happens if we don't initialize things. Now, I just want to do my for each loop to output all of those names. Each of them are a string. We'll call it 1 this time, so we have a different name. And we just want to add this one to our message box. So let's add this one plus a new line. After our for each is ended, then we'll display our message in a message box. So our syntax is going to be message box, which is the name of the Windows Form class that lets those little pop-up windows show up. And the message box class has several methods available, well, a couple anyways, to show and type of. So we want to use the show method. Now, in the show method, you can tell from the IntelliSense, there are lots and lots of different options available. So we could pass many different parameters with different types of settings. Basically, we're always going to start out with a string that's the text that we want displayed in our message box. So for our message box, we want to display the message that we built. If we've done everything right and we run it, we should see our little message box here with the names displayed instead of that console. Not much different. We have an OK button here. We can actually customize our message box quite a bit. So if I put a comma after my message variable and I look at the IntelliSense options, it tells me the next thing the message box takes as a parameter is another string that would be used as the caption. So let's put that, let's create a caption here, our names app. And let's run that again. And now we should see our message box, but it should have our title. So now we're getting all fancy here. We can use the message box even more and go just a little further. The next thing we could add would be buttons. So we could say that we wanted certain buttons. If we wanted message box buttons, we could have abort, retry, ignore. You've seen lots of message boxes that have those buttons. We could have just the OK button like we are right now. We could choose OK and cancel, retry and cancel, yes and no, yes, no, and cancel. Now for our little application, the OK button is really fine, but let's try using the OK and cancel button just so you can see how easy it is to customize that. Run it again, and now we should see the OK button and the cancel button. Okay, so our foray into message boxing, you guys can use that as you look at those Chapter 7 examples, because they do kind of switch over to that as we're getting ready to start working with Windows Forms, kind of thinking about it. So that's all we need for that little application. Let's do a save all on everything. Everybody's working okay, because that's a really small example. But remember with that one, if you want to create some comments, that would probably be good. We had to add a reference to system.windows.forms in the project references. And we had to update the output type in the project properties. It gets to where you wanted to make some notes, but you don't want to write another book. So you have to remember where some of those things are. Good, good, good. Okay, let's do one more and get one that's going to look like kind of the solution that we need for us. So I'm going to add another new project. And let's see what they have in our book. I'm going to name it the same thing as they name it in that PDF document.
This time are we doing the Windows Forms app? .NET framework?
We don't need it for this one. Okay, this project I'm going to call Average Diff. Average Diff. And the only thing that we're going to need in our using clauses is our system console. Now in this first example, this, like I say, you can take this and customize it to be your homework assignment. But we're going to put everything kind of in our main. We're not going to have methods. And as you go through the chapter in the PDF document, you'll see they'll split some things out into methods and then even split some things into classes. So it's really, really good practice for you to go through those projects. For us to start with this first one, though, we're going to be prompting the user to enter test scores. We're going to allow them to enter up to 10 test scores. But that's going to be a limit because we're going to have that size of our array limit. For each test score that's entered, we're going to make sure that it's valid numeric data, but we're not going to have a range test like you guys have to add for the homework assignment. Then after we get the input, we're going to save it in an array. After we've received all of the input, we'll go through the array to sum everything up to calculate the differences and all of those kinds of things. So to start out, we need some variables. And we're going to create a variable that's going to be our total. We'll have some double variables, an average and a distance. The distance is going to be how far each entry in our array is from the average. so that as we loop through our already built array, we can determine kind of the offset of that each number. We're going to create a string to hold our input value from our user. And finally, we're going to keep track of all of the scores that are entered in an array of integers. This array of integers is going to be named score. And like I said, we're only going to allow 10. So we're going to set it to a size of 10. Working on my average diff program, I see I need to rename my program.cs. I'll rename it. So now I won't get lost on which one I'm looking at. I will also go ahead and mark that project as the startup project. Need to make a to-do list of startup things. And then Microsoft will find our list and make it all happen automatically, which would be great. Okay, so first we're going to be entering our values, prompting our user. The way they've done this in our book is with a for loop, and that's fine. We'll use that example. We're going to use an integer here to control this for loop, and we're going to name that integer I and initialize it to a value of 0. And we're going to execute our for loop while I is less than the length of our score array. So we know right here, we just typed 10, but that's the length of our scores array. Why don't we just type 10 there?
Makes it easier to change.
Could you guys hear him? Makes it easier to change it. So I don't want that 10 hard-coded throughout my code. I just want to have one or minimal number of places to change that if I want to update it. So we don't want to use that value throughout our code. We want to use the score.length property of that array class that will be dynamic.
Telling me that I have an invalid Boolean and something else. Expecting a different.
Let's finish our for loop and see if it's happy then. So we're going to say at the end of our for loop that we want to increment I. Because, yeah, you should have an error until you finish that thing.
No, I'm still error now.
You got your curly braces.
Yeah, I'm still error now. I'm not.
What is on? What's the error on?
It's underneath the Boolean, and then I have one under I score.
Where's we don't have a Boolean.
Oh, sorry.
That's okay.
No, it's, I don't know.
You want to share?
Sure.
Let's see it. See if we can figure it out. Okay. Yep, put the I before your less than.
Oh, okay. Maybe that's the problem. There it goes. Thanks, guys.
No problem. Have our right operand and our left operand. So in our for loop, we're going to ask for a score. Enter score. And then we want to have a number. So we're going to use a parameter here and replace that parameter with I plus 1. So this way, instead of saying enter score 0 for the first score, we'll say enter score 1, enter score 2. And so we'll always be adding 1 to the value of I so that it's more meaningful to our user. So that's going to be our prompt that's going to use that I value from our for loop. Now we want to read in whatever the user types into our in value variable. And then we're going to use the try parse to output that variable directly into our array if it's a valid integer. So we're going to use the if statement, and we want to use int.tryParse. What we want to parse is that input value, and we want the output to go to our score array into the position pointed to by our index value I. Now, because we did an if statement on this try parse, we're going to put in equal false to see if that comes out as not true. Now, in some of our earlier examples, we just put an exclamation point at the beginning to make it be not. This comes out to the same exact difference if it's not valid. Now, if the input's not valid, we want to display a message to our user. And we're going to display a message that just says invalid data entered. And I'm going to add some more. We're going to say 0 stored in the array. Now notice in this example, we're not going to go into any sort of loop or anything to ask them for additional data. That'll be a little different maybe than what you have to do for your homework. You might have to go into a loop there to keep prompting them. So when we get past this if statement, we either have a new entry in our scores array at position I, or we have a value 0 saved in our scores position array at position I. Because try parse is always going to output a 0 if it can't output the value. So now we've got something in the array at that position. Notice we're going to kind of force the user to enter 10 numbers here because they have to fill it up. Now we're going to loop through our array or traverse the array to sum the numbers or scores. Now we could use a for each loop here, or we can use a for loop. We'll use a for loop just for a little bit more practice. So again, we're saying that we want to use an integer named I to control our loop. We want to initialize it to a value of 0, run through our loop until we've processed each entry in our array. Now in this loop, all we're going to do is add to our total. We want to add the score that's in position I of our array to our total. Got something, oh, I've got it within my other for loop. Sorry, I got sideways here. I was doing that inner for loop. That should be outside. Let me zoom so you guys can see that. So we should have a for loop controlled by a variable I that asks our user for input. Then that loop should end. Then we should have a for loop that doesn't ask anybody for anything, just sums up all of the scores. Notice even that it's suggesting to me that this could be replaced with a for each. I'll leave it as a for though. So make sure that is all the right way. And then we've got our total. So now we can calculate our average. Whenever we calculate an average, we need to know how many we counted in our total to use as our dividend. And we can use the length of our array for that because we're going to force the user to enter 10 entries. So the length of our array is going to have the right number. It's giving me kind of a light blue squiggly. What's that saying?
Possible loss of track.
Ah, it's a hint. It's a little hint. Well, our total here is an integer. Score dot length is an integer. Is our average an integer?
No.
It's a double. So is there something we could do? Could we convert it? Could we cast one of them? We haven't done that much. Let's just cast one side of our equation as a double, and that'll force the whole thing to be a double. Now let's output. We're going to output our average information. They want a nice blank line. You guys love those. And then we're going to say average and output a parameter to hold our average. We're going to use our average variable. Because it's a double, we have to convert it to a string. And we want to use a fixed point output with 0 decimal places. Let's see what we've got so far. Let's run it. One thing before I run it, I'm going to stop here. I really don't want to enter 10 scores. We've got a limited amount of time here. Let's change our size of our array to like 3 for testing purposes. And then we'll see the benefit of not having to duplicate that number throughout our code. Okay, so I'll do score 1, 30, 40, 50. I need a read at the end so that it will sit there for me. Looks like it was working. 30, 40, 50. My average is 40. So awesome. It looks like it all worked. But at this point, we don't really have any reason that we saved everything in our array, do we? Because we could have just been adding these numbers to our total as the user input them. We haven't done anything that makes us need that saved array. So let's do something that makes us need that saved data. Let's output something else. They say they want to output how far the array element is from the mean, which is our average. So we'll do a blank line. And then we're going to write out kind of a heading. So our heading will say score with a tab character, and then DIST, meaning distance, from AVG, meaning the average. So that'll be our header. Now our last for loop, again, we'll control it with our integer I. We're going to calculate our distance variable, and we're going to use the math library, math.abs, which is our absolute value. So no matter whether the number is positive or negative, won't affect this calculation. And what we want to do is take the average that we calculated minus this score that we're looking at to know what the difference is. So if this score is, higher than the average to where it would go negative, the absolute value function will make it not be a negative result, if that makes sense. And then our final right line is going to be kind of messy. We're going to output, first of all, as a parameter, our score, followed by a tab and another tab, and then another parameter, which is going to be our distance. So let's do our replacements. Well, actually, let's just do the interpolated strings. So instead of a 0, I want to do score sub I. And instead of 1, I want to do distance dot toString F0. Ugh. It was already ugly enough without those replacements. I think our interpolated string is a little bit more readable. Notice how we start getting the square brackets and parentheses and curly braces, and you guys start earning your money as programmers. Look at that and say, what? You got it. All right, see if it's working better now or giving us that output. So adding in this last for loop gives us a reason that we had to save all that data in an array, because we needed to save it to be able to compare each entry to the average, right? We wouldn't have been able to do that if we didn't have the average yet. So if we run it, should see 30, 40, 50. And that looks perfect now. Our distance from average, mine are all 10 because I did those easy to average numbers. It looks good. Now, that is definitely going to require a little bit of changing up for you to use for your homework, but it's super close, which remember sometimes can be worse than super far away. So you may want to just start over from the beginning and just refer to this if you need to, because it might be harder for you to change this than to create your own. So let's save it all. Yes, ma'am.
Not sure what error I'm getting. It's saying that it's affecting an Android's file and it's upset with my.
Oh, you're missing a curly brace somewhere. So we should have 3 at the end.
I have the board. Well,
Did you click on curly brace?
Okay. So I'm looking at that PDF document about page 418 at the end of the chapter. This will be our lab for today. We're going to take a look at this application, and we're not going to get through it all the way. We're just going to get started on it together. But it's an important one because it gives us an opportunity to take a class and store
instances of our class in an array, which gives us a huge amount of capabilities in object-oriented programming. So in this application, we're going to keep track of manatee sightings. So anytime someone sees a manatee, it's going to be logged. So we want something like this solution here, where we could have some sort of location and the average number of sightings each day, the months with the most sightings, the day of the most sightings, and then some sort of count for that day that was the most sightings. So some design work has gone on, and the decision has been made to use the following design. We've got a UML document here. What we're going to have is the Manatee app. This will be our tester application. So look at the way this book does these UML documents, a little bit different, but we can still gather our information that we need. It's actually very good. So in our Manatee app, we're going to have some different things going on, a few variables like our location, sighting count, the array of days, an array of counts, and one method that lets us get data. So our Manatee sighting class is going to have most of everything that we need. It's going to have the location of the sighting, the date, and how many manatees were seen. And then in our class, we're going to have several different methods. One to calculate the average, finding the place with the date with the most sightings, getting that date with the most sightings information, getting that month. So a lot of different methods in our Manatee sighting class. Notice that's what's doing the work. Because if we think about our design, an object-oriented design, this application is supposed to keep track of sightings of manatees. So our Manatee sighting class should have the majority of the work and the data contained within it. So we say anything that has to do with seeing a manatee should be part of our Manatee sighting class. So we have some specific properties and data variables for our Manatee sighting class: location, date, and the count. So pretty simple data-wise. So let's create an application here. I'm going to create a whole new one. This is going to be a console app, and I'm going to make the solution name be chapter 4A Manatee sightings. And then the name that I want to give my project is going to be Manatee app.
So we're making a whole new solution.
Yep, I made a whole new solution. And if you didn't, and if you kept it within your previous solution, that's fine too. We're just going to have a few different components in this one, so I didn't want it to be too messy for you to look at up here. So I want to rename my program.cs to be Manatee app. And again, we can name it driver or tester or anything like that. That would all make sense here for this controlling application of our Manatee sightings. We've got our Manatee app here. We need our Manatee sighting class. So let's add that class. Manatee sighting.
How do we add that?
Right click on your project and then add. And it's at the very bottom. class, and it's also Shift-Alt-C. Now for our Manatee class, our Manatee sighting class, this is the one that's going to have our data. We're going to have private class variables. Let's put some comments in. First of all, I'm going to get rid of a lot of these unnecessary using statements. Above my class, I'm going to do the 3/ comments and put something in about this class. It is Manatee sighting. One day. Track Manatee sightings. Now, whenever we're working with our class data, there are some things that we can do to help keep us organized. And one thing that we can use is a pound sign region statement. The pound sign region statement is, since it starts with a hashtag like that, that means it's a compiler directive. So the compiler is going to look at it, say, do I care about this? Which it's not going to care about it. It's going to throw it out. So we just use the region statements to help us organize our code. So in this pound sign region, I'm going to say class private data. Now I want to end that region so that I don't get errors. So I will do that too. So I put pound sign end region where I want to end it. And I'm basically creating a collapsible point within my code myself. So now I'm going to have a plus and a minus. If you notice right here by this region statement, I can collapse it or expand it. So I'm going to put all of my private class variables within that region. I want a string that holds my location. I want an array of strings. That holds sighting dates. And I want an array of integers to hold the count, our Manatee count. Whenever we create an instance of our class, remember we need a constructor to specify how that instance should be created. So let's put a region statement in to say, here are our constructors. And I'm going to put the end region in so that I don't have to worry about an error later. Now, for our Manatee sightings, we're going to have several constructors. First, we're going to have a default no arg constructor. When we're practicing with constructors, remember the no arg constructor is always public and it's always named the same as our class, exactly the same. In the parentheses, it has no parameters because it expects no arguments to be passed to it. That's why it's the default no arg constructor. Now, in our default no arg constructor, if you remember from some of our other examples, we set defaults. We said, oh, we're going to set the location to Swaziland or default location, and we're going to set our sighting to something else. We could do that. In this example, we're not going to. We're just going to leave everything with no value. Okay, our next constructor that we're going to create is going to be run if we're past only the location. So I'll put a comment to that effect. Constructor that expects only location. We're basically allowing people to create an instance of our class that doesn't have any data with that know our constructor, and we're allowing them to create an instance of our class that only has a location with this location constructor. We would assume then after they create that instance that they're going to come back and add in the data that's missing so that it's a valid manatee sighting, because right now it would be missing some information. So our full constructor is going to ask for all of the information. Our full constructor, again, named exactly the same as our class. It expects a string of location, an array of strings to hold all of the dates, and an array of integers to hold the counts. And if we get all of that information passed to us, then we're going to update all of our class variables appropriately. So we're going to set our site date of this sighting. We're going to have to look at the debugger and see what that's doing. We're going to set our manatee count equal to a new integer array that's based on the length of the array that was passed to us. So take a look at both of those.
We got passed in an array called date. We're going to create a new array, our site date array. We're going to allocate it in memory. And the size we want it to be is the same size as this date array that was passed to us. Then we're going to create or allocate our manatee count array in memory. And its size is going to be the same size as this count array that was passed to us.
I'm getting an error on the location constructor. The same with the location that
So scroll up. It should be up here in your private class data. You see it?
oh, never mind.
You guys found it? Good job. Thanks, Jeff. Okay, so in this constructor, we're going to continue on now. We're doing some array things. We are going to use the array.copy method to copy that array that was passed to us, that date array, from position 0 in the date array into our new site date array, starting at position 0. And we want to copy all of the entries in that array to the new array. So notice I can't just say site date equal date. If I said site date equal date, date is located somewhere in memory, like position 1, F9, E0. And that's the reference to that array, right? That's where it starts in memory. If I do this kind of statement, that just sets site date to point to that same location in memory, just like if we were passing by reference that we were talking about last time. So now I don't have a copy of this date array. I just have two names for it. So any update that I use, this name is going to be reflected in this date array. They'll both be kept exactly the same. That's not what we want. In this case, we want our date array here to be completely copied over to a new location in memory. So we're going to copy it with that array.copy thing. So if we just set one array equal to another, we're just setting it to point to the same memory location. Now we also need to copy the other array then. So each time we're saying, copy this array starting at this certain position to this array in this position for how many entries? Well, we want to do it for however many we have in our count. Finally, we can set our location the same way we did before, because it's just a plain old nice variable that we can use very easily. So now our constructor has all of these great things built in that we can do with it. They want us to have one more. Let's copy this one because it's pretty big. Now I'm going to copy this whole constructor. So make sure you start at the end of the constructor, the closing curly brace, and get the constructor header so that it's all together. And this one, we want to add one more thing. At the end, after the int array named count, let's add comma int num of flights.
Wait, on which one?
It's at the very end. So we copied it and added this new parameter, num of flights. Now we're going to use num of flights instead of all of these length array parameters. So I'm going to copy it, just num of flights, and I want to use it as the index value. Whoops. Stop. Oh, I just messed it up. I just want num of flights. I'll just type it. It's being a real jerk. So instead of looking at our array length, we're going to use this variable, if it's passed to us, to know how big each of the arrays are. Make things just a little bit simpler so that we don't have to keep referring back to those array properties, but not much different. So our two full constructors, one expects how many entries are in each array to be passed to it. The other one doesn't. Okay, I'm going to zoom out just a little bit so you can see and make sure that we're all on the same page here. Your end region statement for your constructors should be after that very last one. I'm going to say this one is full constructor with count, and this one full constructor without count. Now, the reason we wanted to put those region statements in is if we go up and find our region statement for our constructors, we can collapse all of those constructors down, collapse that code down, so that it's kind of out of our way, but yet we can access it really easily if we want to later. Okay, so the next thing that we need for our class are the properties. I'm going to expand my region and make sure I'm in the right place here. And I'm going to do a # region and say, these are going to be our public properties Now, our properties are where our class exposes the data to the outside world. So all of our data that we're keeping inside of our class, this information about manatee sightings is all private. We're not going to let anybody access it unless they use our public properties to do so. Now, to create our public properties, we've had a lot of problems with these because of issues with our other tools. So we know Hypergrade and REPL both have gotten upset, you know, about some of those lambda expressions. So we need to make our properties a little bit old-fashioned because of some of the tools that we're going to use. So to create our property, let's step back and do it from the very beginning. We start out with the keyword public and then our data type. The first one we have is a string for our location. When we specify an automatic property in C#, we call it an automatic property because C# is going to take care of some of the aspects of it. And one thing that is an important aspect is getting the data for other users. So one of our special keywords here is the get clause. When we issue a get, we want to return the data that is associated with this property to our requester. So our get code says return the location. Now the other keyword that we have is set. When we set something, whoops, I've got to get that within those double quote, within those curly braces. When we set something in C#, C# is going to pass us a value, and we're going to take that value and use it to update whatever variable is associated with this property. So in our case, for uppercase location, that property is associated with our lowercase location property. So for the getter, we return that variable. For the setter, we update that variable. Okay, so we need that for location. We need a property for our site date array. So public string array named site date. Now we've seen our conventions are that we name our private class variable with a lowercase letter at the beginning, and we name our public property with an uppercase, HT. But we don't have to. That's just a convention. Now in our getter, we're going to return our site date array. And in our setter, we're going to update our site date array. Nope, yep. I did it in both places, huh? See how easy it is to be consistently wrong? Okay, so our site date then, we have our property for it. And I need to indent all of that. And our last property then is going to be our integer array for our manatee count. Now in our manatee count, our getter is going to return that manatee count array. And notice when we're working with our arrays, we only use the square brackets to specify it is an array data type when we're using data type specifications. Now our setter is going to set our manatee count variable equal to the value that was passed to us by C#. Now we have everything nicely controlled in our class here because we're saying, no, we're not going to let anybody just go update our location variable without letting us know. We're going to control that. So let's go to our tester and see if we can create some instances of our manatee sighting. Manatee app. They've got some ugly, ugly code here. Can we do it ourselves? Let's see. We're going to start it. Are you with me? We can do it. We'll put this whole thing in. I want to create a manatee sighting. And we'll just call it Site 1. We have a lot of code to put in to get our manatee sighting class all up to where they want it. So could we say that we had a manatee sighting in some location? Are manatees in Argentina? Or are they just in? Do we need the new keyword? Oh, you're so good. That's why it's mad at me. So that let us create an instance of our manatee. We didn't do much with it there, did we? We should add a toString to our manatee class so that we could print out information about our class. Let's do it. Let's go to our manatee sighting class. And after the end region for our properties, let's put in a region statement for instance methods. These are the methods that we have set up in our class. And I want to do our override of our toString. Oh, they have a certainly ugly one. So let's see if we can do this. I think we can do it. We're going to start out with a tab, then the word location, followed by a colon and a space. And then we want to add our location variable. The next thing that we're going to add is going to be 2 new lines. Then we want this heading, average number of sightings. And a tab. Now on the next line, they want us to run a method and we don't have that created yet. So I'll put a comment here. Calculate average method call goes here. And then I'll continue on. We're going to have 2 new lines again. And say month name for the. The next line is going to start out with a new line. So it says month name for the, and then a new line, and date of most sightings. And 2 tabs. Getting really specific here, and of course we could get much more creative with however you wanted it to output. Just want you to see how specific things can get. Now, after this date of most sightings, we're going to use a call to get month with most sightings. our next line is going to have 2 new lines again and say date of most sightings. And a couple of tabs. I'm going to leave that there. There's a few more things that we could add after we've got some methods in place. It's getting too messy. So I want to put my end region after this method, because that is the only method that I have right now. And now our region statements are just keeping us organized. Remember, they're compiler directives that don't really have any impact on the code that we're creating. They're just compiler things. All right, so our Manatee sighting app is coming together quite nicely. We have a lot of information in it. Let's right-click on it in the Solution Explorer and do that View Class Diagram. And if you expand that, remember, it's going to be giving you that information that we were seeing on that original UML document from the textbook, showing us how our class is coming together. So we have our fields and our properties. Now, down at the bottom of the screen, if you expand that area down there, you'll see that there's another listing of all of this class information. You could actually use this graphical area here if you wanted to build your class. Yes, sir?
Mine's not working.
It's not showing it. See if you can grab down there and pull. You get it too hard. There it is. So, wait till you get that too hard. There you go. Then you have to be looking at your class. Oh, yeah.
Still not working.
Are you ready?
No. So let's see what it says. Yeah.
I think it's the same error over or something. I was trying to think.
Yeah, I always say something because when we get too far, it's really hard to figure it out.
Claiming that these are already declared, which is really weird because there's nothing that's.
So did you want your Oh. This is the okay, so here there's a huge that is right like that. Severe fraction go up. Yeah, but that's nothing. So get rid of it.
I'm not sure why. I'm not sure
It's
why.
just when you follow, when you guys are following along, you do amazing. I don't know how you do it. So should that int have the square brackets in your property? There, because that's going to be a table. So where that is. Oh, yes.
How do I fix this? This is the main location. Right there.
Here's where it's declared. And so this is outside of the current business. Let's give it to Okay, so anyways, you can use this class view to build your class if you want to too. So if somebody tells you to create a class, the main thing I want you to know from this is it's super easy. You can, if you can't remember how to do the code, you can't remember how to write code for the getters and setters or whatever the problem is that you're having, you can just go to this class diagram view and type it all in down here and it'll build all that code for you and generate everything for your class. So you can do it.
Didn't you have this for the animal class video?
Uh-huh.
Because I remember watching it and being
Yeah.
like,
You
I
can
wasn't
do
sure.
that if you want. Yeah, for some reason it gets everybody all confused. So it's just like, I won't even show it to you until later because you guys are just such good coders, I guess. You don't like all those graphical things. A few years ago, everybody loved them. Everybody loved them, but you guys are just too tough. So what we've got here is we've got our Manatee class or Manatee citing class structure built, but we're missing some methods in it. And so our tester can't do all of the testing that it wants to do because we're missing some of those methods. But let's put in our tester the little bit that we do have in our Manatee app. I'm going to come back and say that I want to do a console.writeLine on our Manatee citing instance. So that would be site 1. Now, whenever we mention an instance, the default method to get run there is the toString. So when we just say site 1, which is our Manatee citing instance, it's going to run our toString method. Let's run that. I'll put in a read afterwards. And then I don't have any data because all we sent was this location. So we are seeing our location of Argentina. But we don't have any dates and things like that. The rest of it's blank, but we are getting some information out from our class. Now this one is all in the PDF that I've given you, but it can be kind of hard to follow. So I'll go ahead and set up a Zoom session and record it in case you want to watch that. Some people hate them, some people like them, so it'll totally be up to you, but I'll try to do that as soon as I can so that you can look through that and get this done before next week. Because we'll be moving on, you know, of course, like we always are, from our array topic. We'll have more time on Monday to focus on it, but I think it would be good if we got a lot of this done offline looking at Zoom. I'll take a look, and if I do get the video made, I'll send it to you. If it looks like we have enough time to do this on Monday, I'll send you a message and let you know so that you know which way we should go. I was hoping we would get a little further in it, but we are just got a lot done today. I think we got some good practicing with arrays in. Got to see how to do a message box in case you want to look at the PDF document. Anybody got any questions before we break, get out of here? I hope you have a great weekend.
Repo question.
Yes, sir.
You might have to come look at my output.
Are you getting the weird garbage characters?
Yeah, it's the same one that Noah was getting yesterday.
Right, and that's what we were talking about. Did you go to that bug site and upvote that for me so that they
Yes.
would know how serious it is?
Yes,
That's all I can do about
do
it.
you mind if I submitted it?
No, that's fine. Go ahead and submit it. 'Cause, yeah, we can't get around it. So submit away, and I'll just mark them as complete.
All right, thank you. ma'am.
Or you can wait, either way.
That was
They're
my
driving
question,
you
is
crazy.
I was like, well, she's aware of the situation, so there is a.
Oh, yeah, I'll
see
I'll
what it is.
no
Yeah,
problem.
that's kind of was my.
It's just driving everybody crazy.
I'll go here.
Did you figure it out?
Six,
Jen, then?
window,
Let's get these together and better secure.
Truffle slash.
Yeah, slash bug. And any you see like that, do let them know, because we're using it